Hi Trigoners, this is Sequences Day 2. So we're going to be looking at the explicit formula for a geometric sequence. So remember that a geometric sequence is one in which you get other terms by multiplying by the same number, and that same number is called a common ratio. So if you did 200 divided by 40, you would get 5. If you do 40 divided by 8, you get 5. So in that backwards direction, you would divide. In the forwards direction here, you would multiply. That's only because this sequence is getting bigger. You can look at a geometric sequence as a decreasing function in which the numbers would divide in the forward direction and multiply in the backwards, but it's just the exponential relationship. So 40 represents the second term, 200 is the third term, 1000 is the fourth term. If you multiplied by 5 again, that would be the fifth term, so that's 5,000. And then you multiply by 5 again, and that's 25,000, and that's the sixth term. So we're always multiplying by 5 to get to the next term. So our process here is that you're multiplying 8 by 5 to the 0, because the first term is 5 to the first, which means that this has to be the 0th term, the 0 exponent. And if you remember, 5 to the 0 is equal to 1, so that's why this makes 8. A sub 3 is 8 times 5 squared. You've multiplied by 5 2 times to get you to 200. A sub 4 is 8 times 5 times 5 times 5. A sub 6 is 8 times 5 fives. And if you notice what the formula would be, if you fill in all of these boxes, this number here and here are related for every single one of these terms, that the exponent is always 1 less than the term number that you're trying to find. So 5 is 1 less than 6, 3 is 1 less than 4. So your explicit formula will take your first term and multiply by r to the power of n minus 1. So the general explicit formula for any geometric sequence is this function right here. Realize that this is just an exponential relationship, and the reason that it's n minus 1 is because this term number is 1, and that represents your, well, it's your first term, but it represents your initial condition. And it's also not the y-intercept, because the y-intercept would be if you plug in 0 perfectly, and this is a sub 1, which represents like 1 on the graph. Let a sub n be a geometric sequence. So one thing you have to know whether a sequence is arithmetic or geometric to be able to use the equations that we've talked about. So if a sub 1 is 48 and a sub 7 is 16 over 243, the question is find r. So I'm going to use this and plug in everything that I know. So I know that my first term is 48, and I know that n is 7, so I'm plugging everything into this equation. And now I just have to simplify and solve for r. So I'm going to divide both sides by 48. And that's going to be equal to r to the power of 6. So to get r by itself, you're going to have to take the 6th root of both sides. Because 6 is an even number, you're going to have to remember the plus or minus. So it's okay that we have a plus or minus here for your r value. You get plus or minus 1/3 when you take the 6th root of this fraction over here. So what this says is that we could have a strictly positive sequence. All of the terms could be positive. Or it says that the terms in your sequence could alternate because of this negative. And the thing is, we have no way of knowing whether this sequence should alternate or not based on these two numbers that they've given to us. So that's why the positive and the negative cases are important. Part B, write an explicit formula for a sub n. a sub n is equal to 48 times plus or minus 1/3 to the n minus 1. And part C, find a sub 6. So I think you can do this two different ways. You can use your explicit formula, in which case you'll end up with two answers. You'll end up with positive 16 over 81, or you'll end up with negative 16 over 81. The other way that you could do it is knowing that you had a sub 7. And in the forward direction, your common ratio, like if you were to go to get a sub 8, you would have to multiply 16 over 243 by 1/3. So therefore, in the backwards direction, to get a sub 6, you would divide by 1/3, or plus or minus 1/3, which is the same thing as multiplying by positive or negative 3. So I think you can think about it in two different ways. All right, moving on. Problem number 2. A sub 3 is equal to 8 and a sub 7 is equal to 2048. So we don't have our first term, but that's okay. We're going to plug in everything that we know. So 8 equals a sub 1 times r to the 3 minus 1. 2048 is equal to a sub 1 times r to the 7 minus 1. And what's nice is that you have two equations and you have two unknowns, and now you can solve a system. So a sub 1 is going to be equal to 8 divided by r squared, and then this can be substituted in over here. So 2048 equals 8 over r squared times r to the 6. 2048 equals 8r to the 4. Divide by 8 and take the fourth root. You end up getting plus or minus 4. Therefore, your explicit formula will be plus or minus 4 to the n minus 1, and the only thing left that we have to find is our first term. So again, you can find that first term a couple different ways. I'm just going to show the easiest way right here. So here is my formula for a sub 1. A sub 1 is equal to 8 over r squared, and regardless of r being positive or negative, this number right here will always be 1/2, because plus or minus 4 squared is 16, 8 divided by 16 is 1/2. So there's your explicit formula for a sub n. A sub 11 equals 1/2 times plus or minus 4 to the power of 11 minus 1. And your answer is plus or minus 524,288. The recursive formula in a basic sense is similar to what we did with arithmetic. You need to have a starting place and you need to have some pattern. And because it's a geometric sequence that we're dealing with today, the pattern is going to be multiplication. You have to be multiplying by that common ratio. So here we need to figure out our r value. So take a second and figure that out based on things that we've done today. All right, once going through the work, you should end up getting that r is equal to plus or minus 1.5. And your first term, because that should be equal to 3 over r squared, this will be 3 over plus or minus 1.5 squared, which is equal to, you should get 4/3 for your first term. So your recursive formula for a sub n has to have the two parts. It has to have a start and a pattern. So our first term is 4/3, and every subsequent term will take its previous term and multiply by plus or minus 1.5. And then I need to say for integers n greater than or equal to 2. So this was something I didn't write on Tuesday and Wednesday, but it really is important because sequences are patterns that only allow for whole number inputs. So you can only plug in 0 and 1 and 2, you can't have decimals. So that's why it makes sense that you can say for integers n greater than or equal to 2, because it forces n to be 2, 3, 4, 5, etc. Like I was saying in the other video, you can actually have a beginning of 0. You can have a beginning of 2 different starts. And so that's why I say a recursive formula has really just 2 ideas to it. It's got a start and then a pattern. And so this satisfies the geometric. For any geometric sequence, the recursive formula will have the previous term times the R value. Find a sub 11. I'm going to show you on the calculator the easiest way to do recursion, and this will work for arithmetic and geometric sequences. Okay, so you can start in a few different places. You could start with a sub 1, you could start with a sub 3, but because in this problem they told me that a sub 7 was 15.1875, I'm just going to start there and I'm going to put that into my calculator. And because this is geometric, I'm multiplying, so I'm going to multiply by 1.5, and that gets me a sub 8, and then hit enter again. A sub 9, a sub 10, a sub 11. So then you can write your answer at 76.89 if you round to the nearest hundredth. So that's how you would do geometric, because you're multiplying. In a linear situation, suppose your first term was 4, and you're always adding 2, you would just do plus 2, and then enter, 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 and that right there would get you the first 4 terms of your sequence. So going back to our sheet here, a sub 11 is 76.89. A couple reminders. I just want to make sure that when you guys write recursive formulas, you give me your start and you give me that pattern, and you write what that pattern is good for. And for integers, n greater than or equal to 2 is what's going to be good for our class. But realize that as you get older, in more advanced classes, that might change just a little bit. Bye.